Welcome to video number 2. This is Chef Jack coming to you live from my basement. This video is going to go through our first PowerPoint lesson. So, under the announcements page, if you scroll down, you'll see this week you're going to be reading the Gislin book. And if you've got 9, it's right here. Now, this one announcement is for my 200 and 201. So next Monday is when you'll have to be done with turn in this outline, the discussion, and the quiz. For my 201 class, you've got until the following Friday. Go back to our 200 and 201 because that's on Mondays first. And they're all the same classes, so I'm just going to do one video for one. Hopefully it's not too confusing. Again, it's just all the same material. But whenever your quizzes are due, whenever your class time would have been. So we're going to go down to Module 1, and then we're going to go into Module 1, Heat. And then what I would recommend you doing is clicking on the outline, which is going to look like this, and either print it off or just keep it on your computer, on one frame of your computer, and then you can watch this video or do the PowerPoint and fill it in. The PowerPoint, if you click on the PowerPoint, you'll see the PowerPoint will come up, and then here's an outline of kind of example of a completed outline. So again, here's where you would, as you do the reading, you'll just fill in these parts. But then as you'll notice that as I go through the PowerPoint, a lot of the answers will be also in the PowerPoint. So the idea is to do the reading, fill out the outline, and then use the outline to take the quiz, and then also you're going to submit this outline. The video, once I'm done creating it, will go here. So you can watch this video and also work on fill out the outline and then submit it. And then you can submit your outline here and then take the quiz. So without further ado, let's start with our PowerPoint, which I know everyone's waiting for. So we'll start at the beginning. And again, I'm not going to read all of these, but I'm going to try to get through it. And I'll watch the time. If I get a little bit long, I might break this PowerPoint up into 2 different videos, but we'll see. So culinary science is really the food science principles as related to cookery. The first thing that we'll look at is heat. Some of the things that you should know after the session: what is heat, how is heat transferred to food, and how does heat affect food. A cook's judgment. No recipe is 100%. The judgment of a cook is still the most important factor. And as you go through all of your labs, this is what you're going to be refining and kind of, I guess, tapping into, your feeling, your understanding. All, ovens cook differently, foods cook differently, raw ingredients are different. So a recipe can kind of point you in the right direction, but it's going to come down to your innate ability, your thinking, feeling of, should you cook something more, a little bit less? You should whisk it a little bit more or less, faster. And these are all, your kind of your internal gut feeling. There's my little heat guy. I got to add a little humor to our PowerPoint. This is what I do on the weekends. I kind of come up with this funny stuff. Anyways, starting on page 112, the 9th edition, temperature, is simply a measure of molecular activity. How hot something is, and it's how much heat is absorbed in the molecules. Evaporation, as you cook something, the gases come to the surface and release as steam. But and sometimes when we're making stocks or sauces, you get natural reduction, which concentrates the flavors. Heat something too long, like a soup or something, it gets too thick. So then you have to add water because you've had too much evaporation. Cooking is enough heat is added to physically change food. So think of it as you apply heat to a clear uncooked egg, it becomes solid and white. And same with a chicken breast. As you cook it, it changes texture, color, taste. Heat affects foods differently, and foods are composed of carbohydrates, proteins, fats, and water, minerals, vitamins, pigments, and flavor elements. Name some carbs. Normally in class, I'll go around and ask everyone what their favorite carb is. And here's a picture of carbs. Sometimes we don't think of these as carbs, but they are carbohydrates. Bananas, pastas, beans, rice, bread, potatoes, corn, carrots. They all contain carbohydrates. Carbohydrates are really made up of different types of sugars and starches. And I won't play this, but if you do go into the PowerPoint, Harold McGee, which is the book that we are not using, but I highly recommend it. This is a link to his website, The Curious Cook, and he's got some interesting things in there. And then this is a Harvard video series, which I'll talk about at some point. Then starches are complex carbohydrates. Gelatinization, if you think of it as how do you thicken a soup or a sauce with presumably with some type of starch, either a slurry or a roux. And what is a roux? Hopefully you can all answer that without hesitation. And how many different types of roux are there? So roux are different, and it all depends on how long you cook them. And as you cook the roux, it's really a dry heat with no water, and the roux turns from kind of a white to a blonde to a brown to actually a black roux for like gumbos and stuff, etouffees. Those roux actually, as the browner they get, the less thickening power they. And then fiber cannot be digested. Softening of fruits and vegetables is in cooking is in part breaking down the fiber. Acids and sugar make fiber firmer. And baking soda makes fiber a little bit softer. And this was interesting when I was going through this in one of my classes. A student from Pakistan actually said, his grandmother always added a pinch of baking soda to her chickpeas, and he never knew why. But she just said, you just do it, just because you do it. And I think that's, I think when you talk about culinary science, some people like to know why. A lot of chefs just say do it. They don't know why they do it, but it works. But culinary science is kind of exploring the nitty gritty of why things particularly work or why you do things. Baking soda and other alkalis actually help make fiber a little bit softer. So if you want to cook your chickpeas a little bit quicker, add a little extra baking powder, soda, but not too much. You don't want to overdo it. Name some proteins. So now we'll take a look at proteins. We've got a steak, some cheese, eggs, and beans. And what kind of steak is this? Do you know? Just thinking. I know I could pause it for a bit. You could pause this for a while. But it's a round steak. So you've got the inside round, the eye round, and the outside round. So this is better for baking or roasting. And then these two guys are a little bit tougher, so you'd braise them. For cheese and egg, you can tell you've got the one white, secondary white, and then the yolk. This is a fairly fresh egg. You can see the delineation between the white and the yolk. It could be a little fresher. Maybe the yolk could be a little bit higher. And, after a couple of weeks, the white would run out farther and you wouldn't see that distinct separation. Effects of heat on proteins. It's called denaturing. Normally in a kitchen we don't call it denatured, but really it's just cooking. Coagulation. The proteins form a solid network of bonds. And again, this is where kind of the sciencey part is. And then really coagulation, think of an egg or chicken breast, as it coagulates, as it cooks, it will firm up. If you overcook it, it's going to get tough, dry, and sometimes if you notice, like when you're cooking chicken or fish, some of that like white stuff will ooze out of the chicken or the fish. Well, that's just proteins being squeezed out from excessive heat. So that's an indication of something's been overcooked. And eggs, in the book it talks about, the egg whites will start at around 140, and then the egg yolks will start to coagulate around 146. So that's why you can have, sunny side up eggs where the whites are set and the yolk is still, because they actually cook or coagulate at different temperatures. The being denatured, it's like this, it starts to separate, and then as it cooks more, you get cross-linking and it firms up. The Maillard reaction is a browning. So when we caramelize something, that's with sugars, but the Maillard reaction is browning of proteins with a little bit of carbohydrates. Again, here's a Harvard video series, and it really is a great little video. And the Maillard reaction starts around 230, whereas caramelization of carbohydrates starts of sugars starts around 300 degrees. And it's amino acids and proteins. And some of the examples of the Maillard reaction would be bread, chocolate, coffees, dark beers, roasted meats. That's all the Maillard reaction. Remember, it takes place on a dry surface. So a lot of times in a recipe, I'll say blot the surface or get it dry because you want that browning, that searing to get that flavor development. Otherwise, you're just going to have a boiled meat. Connective tissue, there's special proteins in meats. And again, think of it when you roast a chicken. If you leave the chicken in the pan the next day, there's like that, I call it the chicken jelly at the bottom of the pan. And that's really connective tissue that's broken down as the chicken is roasted. But that's what gives your sauces and stocks that viscosity texture to them, is the connective tissue as it's broken down. Acid has two effects. It can speed coagulation, and it can help dissolve connective. Fats are found in a variety of items: meats, oils, avocados, nuts. List of them. Some of the key points: they can be either liquid or solid at room temperature, and they all have different heating and smoking points depending on what type of fat it is. Olive oil is very low, whereas peanut and grapeseed is very high. So again, depending on what final application is, it will help determine what type of fat you're going to use, not only for the smoking point but also the flavor and taste. On minerals, vitamins, pigments, and flavors, you gotta like this guy. We don't often think about minerals, vitamins, pigments, and flavors, but it affects the nutritional quality, the appearance, taste, and texture, and we'll look into that a little bit. Components are soluble in water, and some are more fat soluble. So you think of vitamins like B and stuff are more water soluble. Depending on how you cook it, you can leach out some of that flavor, some of the color, some of the nutrients. There's your water guy. Nearly all food contains water. Water exists in three states: solid or ice, liquid or water, and gas is steam. Here's kind of a chart going from ice to water to steam. And some things just to keep in mind of, when we go to shock vegetables, a lot of times you don't just shock them in water, you shock them in ice water. 1 gram of ice can absorb 80 calories of heat. So that's why when ice melts to water, it absorbs 80 calories of heat. So that's why it's much better at cooling things down. If you just use water, your water would warm up very quickly. And then conversely, when water goes to steam, it needs to absorb 540 calories of heat before it turns into a gas. It makes that leap. And that's why if you've ever had a steam burn, now you'll kind of understand, because when that water then hits, or steam hits your hand, it releases the 540 calories of heat into your hand, and that's why steam burns are really painful. Sublimation, that's when it goes from ice to a vapor, and term for that is freezer burn. So these are a bunch of fresh vegetables that haven't been wrapped properly, and it's still edible, but the water has evaporated from the food. Water can turn from liquid to a gas at lower temperatures through evaporation. Minerals can be dissolved into the water, and then when you dump the water. So that's why steaming is a great way. It cooks vegetables quickly. Water freezing temperatures can be lowered by adding salt or sugar, but again, you'd have to add a tremendous amount of salt or sugar for it to really change to affect the temperature.